Household water reliability usually sits in the background until a constraint appears. The constraint can be supply-related, such as drought restrictions, reduced reservoir levels, or temporary service disruption. It can also be quality-related, such as periodic advisories, aging infrastructure, or localized contamination concerns. In many regions, these issues are not constant, but they are frequent enough that some households look for a layer of redundancy. Within that problem space, most backup water solutions fall into categories that require either infrastructure, storage discipline, or ongoing maintenance. One category is stored water. This includes bottled water, packaged jugs, and larger storage containers. The basic logic is simple, but the trade-offs are practical. Storage volume, rotation schedules, container integrity, and the need to keep an inventory that matches household size and usage patterns. The effort is not technical, but it is continuous. Another category is collection and treatment. This includes rain catchment setups, rooftop routing, barrels, filtration, and sometimes pump systems. In some homes, this becomes a small infrastructure project. The friction often comes from compatibility with the property, local climate variability, and the recurring workload involved in keeping containers clean and filtration elements maintained. Even when the system is well designed, it is still tied to environmental conditions and to the owner's consistency. A third category is groundwater access, such as well drilling. This is usually the most capital-intensive route, and it is also the most location-dependent. The workload may be outsourced to contractors, but the complexity is high, and the feasibility depends on geology, permits, and long-term water table stability. A fourth category is appliance-style devices, such as countertop filtration systems, under-sink filters, or dehumidifier-adjacent products that may collect small amounts of water. These tend to lower day-to-day friction, but often introduce recurring consumables, replacement schedules, and limited capacity. Across these categories, the common friction point is that redundancy typically requires either money, ongoing attention, or both. Storage solutions trade technical complexity for inventory management. Collection systems trade cost savings for maintenance and variability. Infrastructure solutions trade convenience for upfront investment and location constraints. Appliance solutions trade ease for capacity limits and recurring parts. This landscape creates a niche for products that position themselves as low installation, repeatable, and independent from municipal supply, even if they require some degree of technical assembly or environmental dependence to function as described. Smart Water Box is presented as a how-to product rather than a conventional physical appliance in the standard consumer retail sense. The core offering is described as a digital guide that provides instructions and a materials list for assembling a household-scale water-related system. Based on the way it is framed, the product's scope is not a subscription, not an ongoing service, and not a managed installation. It is positioned as a self-directed build process. The main deliverable is described as a set of blueprints, step-by-step instructions, and an itemized parts list, alongside general notes about setup, storage, and troubleshooting. The conceptual framing centers on the idea of an independent water supply, described in terms of off-grid resilience and reduced reliance on municipal infrastructure. The material implies that the intended build resembles an atmospheric water generation concept, in which water is collected from air under certain conditions, but the product itself is not presented as a detailed scientific course. The framing stays at the level of concept, parts, and assembly. The marketing narrative included alongside the product leans heavily on urgency, conflict, and dramatic storytelling. That narrative is not part of the functional definition of the product itself. Functionally, the offer is a downloadable instruction package intended to guide a do-it-yourself assembly process using commonly available components. The product also references bonuses, described as additional DIY guides. One is framed around solar water heating concepts, and another is framed as general household DIY savings and repairs. In structure, these appear to be supplementary instructional documents rather than separate physical products. Using Smart Water Box, as described, involves 3 stages. preparation, assembly, and ongoing operation. Preparation is primarily a sourcing task. Time is spent reviewing the materials list, identifying which components are already available, and purchasing the remainder. The complexity of this stage depends on local availability and on whether substitutions are permitted within the guide. The effort here is logistical rather than mechanical, but it still requires planning. Assembly is the central interaction. The product is positioned as a multi-step build process that can be completed by a non-specialist following instructions. Even with clear instructions, assembly typically implies basic tool use, fitting components together, and verifying seals, connections, or routing paths depending on the design. This is a higher effort profile than buying a finished consumer appliance, but a lower effort profile than designing a system from scratch without guidance. Ongoing operation is described as repeatable and routine-based. In systems that rely on environmental conditions, the level of consistency depends on the operating environment. The implied interaction level is relatively low once assembled. Monitoring, occasional cleaning, and basic checks are typical for DIY water-related devices. The product also references water storage and safety handling, which implies that ongoing operation includes some form of container management and periodic attention. The environmental needs implied by the product's framing include a stable placement area and an operating environment compatible with the system's underlying concept. In practical terms, that usually means an indoor garage, utility area, workshop corner, or another controlled space where a device can be run and where collected water can be stored. Noise, airflow, and power access may also be considerations depending on the build design, even if those details vary by implementation. Repeatability is one of the main positioning points. The product implies that once a household has built one unit, the process can be repeated or expanded, but scaling typically increases the burden of monitoring, storage, and maintenance rather than removing it. Smart Water Box most logically fits households that accept a specific trade, more effort up front in exchange for a potentially more independent routine later. It makes the most sense for people who prefer a project-based solution over ongoing purchasing and storage of bottled water, tolerate basic DIY tasks, sourcing parts, and assembling components. Value consistency of process more than customization, meaning they would rather follow a set plan than design their own approach. Want a solution that is not dependent on contractors or scheduled installation appointments. It also aligns with users who are comfortable treating water redundancy as a layered system. In that mindset, a DIY build guide is not a single complete replacement for municipal supply, but one component among storage, filtration, and preparedness routines. Smart Water Box is less likely to fit people who do not want an assembly project and strongly prefer finished, certified consumer appliances, have limited tolerance for troubleshooting and iteration, want high certainty with minimal variability, especially if the underlying concept depends on environmental conditions, prefer solutions that are managed by professionals, even if cost is higher. It is also a poor fit for anyone whose constraints are primarily about convenience and time. Even if the assembly is described as straightforward, the total effort includes reading, sourcing, building, testing, and maintaining. For some households, the friction of those steps outweighs the value of the concept. Compared with storage-based approaches, Smart Water Box shifts effort away from continuous purchasing and rotation and toward a single build process plus periodic maintenance. The trade is that storage is predictable and immediately available, while a build-based solution introduces dependency on correct assembly and ongoing operational conditions. Compared with rain catchment and other collection systems, Smart Water Box is positioned as more compact and less tied to roof routing or seasonal rainfall patterns. At the same time, collection systems can be scaled with large storage volumes, while a device-based approach may be limited by the practical constraints of running, monitoring, and storing output. Compared with well drilling, Smart Water Box sits in a different cost and complexity bracket. Well drilling is a long-term infrastructure investment with location-specific feasibility, while a DIY guide is a lower barrier entry point but also less standardized and more dependent on how the build is executed. Compared with consumer filtration products, Smart Water Box asks for a higher level of initial effort. Filtration products typically assume an existing water supply and focus on improving quality, while the Smart Water Box concept is framed around alternative sourcing rather than only downstream treatment. That difference changes the household workload. Filtration is mostly maintenance and replacement cycles, while alternative sourcing adds assembly and operation routines. Across these comparisons, the central positioning trade-off is consistent. Depth and customization are exchanged for a defined process that emphasizes ease of replication and a standardized path. The product is not framed as a highly tailored engineering solution. It is framed as a guided DIY package aimed at reducing decision-making during the build.